Hi, ladies and gentlemen. How are you today? Hopefully, you're doing really well, and hopefully, you have already printed out your notes page or notes pages for this particular video. And actually, it's going to be more than just today. We'll only be filling in part of it today. We're focusing in right now on weathering. You've done a little reading about weathering. You've watched another video, I think there was, about weathering. Um, but we're going to talk about it for just a couple more days. And part of that is because we're looking at weathering, erosion, and deposition. Um, and we talked in our live class the other day about the fact that there is some similarity between the three because they are basically a process that doesn't always move exactly from one to the next to the next. There can be some back and forth, a little bit like the rock cycle, but there's definitely a process where all three of these can be involved. But they all play their own role in that process. And I think a lot of times when people use the word erosion, they're actually referring to weathering, I think, most of the time. Sometimes they're actually referring to erosion, and sometimes they're actually referring to deposition, but the word erosion gets used the most. We're going to focus on weathering for right now. Hopefully you have your notes there. You don't need to write anything down quite yet, but just to give you a little preview, throughout this unit we are going to be talking about weathering, both mechanical and chemical weathering. We're also going to talk about the mass movement of Earth, or earthen materials like rock and soil and dirt and all of that fun stuff. So that will be coming just a little bit later. All right, but today we're focusing in on weathering. And so this is where you want to kind of write down here our area of focus is weathering. Sorry, I forgot to underline the word weathering there. Um, and so weathering is the breaking of rock into smaller pieces, the breaking of rock into smaller pieces. And I think I kind of mentioned that the other day when I was kind of pounding my fist with the word weathering. So weathering is the breaking of rock into smaller pieces. Here's an example of highly sophisticated animation here of a rock being broken into pieces. Are you ready? Yes, that's right. The rock was broken into pieces. I know, it was pretty exciting. All right, so weathering, ladies and gentlemen, generally can fit into two categories, and we've talked about this. You had a cool down question about it one day, and just about everybody got that correct. The two types of weathering are mechanical or chemical. Again, those underlined words are going to go in your notes. So mechanical or chemical. So sometimes weathering can be caused by wind, as in this case here, where wind, as it blew along, gathered up bits of sand and rock along the way, and the wind hit against a giant piece of rock, for instance, there used to be a giant piece of rock right here. But as the wind picked up little bits and pieces of sand and rock and kind of blasted that out over a very, very long period of time. But it can also be caused by water. Here we have something that looks fairly similar. It's another stone arch, but in this case, the water continued to rush against the rock and eventually wore a hole there at some point that was probably a very large river, much larger than it is now, to have carved out a hole like that. So water can also cause weathering. And the canyon here, as water rushed through the canyon, it broke down the rock in that area and created the canyon. So we're going to focus for probably, well, a good part of the rest of this video on mechanical weathering. All right. And so yesterday or in our live class, I had asked you, um, what did you think the difference was between mechanical and chemical weathering? Well, We're going to kind of find that out now, because mechanical weathering is physically breaking rocks into smaller pieces without the use of chemicals. Okay, physically breaking rocks into smaller pieces without chemicals. And we're going to look at a number of different examples of mechanical weathering, as you can see here. 7 different ones eventually. I don't know that we'll get to all of them today, but we'll get to some of them certainly. So the first one is water. Our first example is water. So the water crashes into rocks, like I mentioned a few minutes ago with the river and the rock creating the arch, causes rocks to hit each other and become smaller and smoother. So the water molecules certainly can have some impact on the rocks, but a water molecule compared to a rock itself, well, it's probably not going to do a lot of damage. However, the force of the water causes the rocks to move and causes them to crash into each other. And as they crash into each other, they actually can knock pieces off from each other, and over a period of time become smoother and smoother and smaller. You didn't use water for this, but many of you did the M&M mechanical weathering lab last week. And in that case, really what caused the M&Ms to change their appearance was not just simply the shaking action, but it was really the fact that the M&Ms are crashing into each other. And as they crashed into each other, they knocked little pieces off. So a little bit similar to what we're talking about here. Whenever you see round rocks like this, especially when you're near a water source, you can pretty well guarantee that those rocks became round because of weathering from water. So round rocks are a sign of mechanical weathering that has happened. All right, so our first example of mechanical weathering was water. Our next one is something called sheeting, or sometimes it's called exfoliation. All right, sheeting or exfoliation. Now, I don't know about you, but when I hear the word exfoliate or exfoliation, I usually think of people wearing those like beauty mask things or something, or scrubbing their face with some sort of, thing that's supposed to prevent zits or something. Because exfoliation simply has to do with the removal of a layer of something. So when it comes to your face, you're removing a layer of dirt and dead skin cells. In the case of rocks, rock layers are peeling off, falling and breaking apart. So here we have some rocks maybe similar to ones that you might see maybe along the highway in places where they've kind of blasted out an area so that the road could go through, and you're left with kind of these stone cliffs on the side of the road. And sometimes exfoliation will happen there where the rocks will just kind of fall right down the side of that cliff area. They just kind of peel away or break apart from the other rocks in that area. Gravity has a lot to do with this. All right, so a little quiz for you. Which picture best represents exfoliation? Do, 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 do. Okay, not that much time. I hope that you said letter A, because A shows exfoliation. We can see here that there used to be some rocks, but they have slid away or fallen away. A layer of rocks has fallen there. We'll talk about what kind of weathering this is in a little bit later. Well, apparently we'll talk about it now. B is actually ice wedging, which we will talk about in just a couple minutes. In this particular scenario, which picture best represents exfoliation? Yes, that's right. It is picture B. Very good. Picture B, where we have these layers of rock that are kind of breaking away from the larger piece of rock. A is actually chemical weathering, where chemicals have eaten their way through the rock. All right, so this seems a little off topic, doesn't it? Well, you'll see where we're going in a minute. So have you ever put a can of soda into the freezer and then maybe forgotten about it there? What happens? Well, I have done it accidentally once. It wasn't soda, as you can probably guess, it was seltzer water. But similar idea because they both are carbonated beverages in an aluminum can. All right, what happens? Well, it tends to explode. Okay, water, when it is frozen, expands, which is actually a little bit of an odd phenomenon. Most things when they freeze actually get smaller because the molecules are getting closer and closer together and not moving as much, and so they actually decrease in volume. But water is kind of odd and special in that it actually expands when it freezes, and so that's what will happen to a can if you leave it in the freezer. Please don't try this without your parents' permission. Please don't get me in trouble. Thank you. Okay, so ladies and gents, if that's what happens when water is left in a freezer, imagine what happens underneath the road when moisture gets into the dirt and into the ground underneath the road. And then winter comes and that moisture freezes and it expands. In fact, water expands about 9% when it freezes, which is a relatively large amount. And so when it does, the solid asphalt road that is on top of that ground uh, is going to have to shift and move, and we get those awful frost heaves in the road, especially here in New England during the winter time. It's because of the ice that is in the ground underneath the road. So here we have the increase of volume, about 9%. This is not anything you have to have in your notes. You're free to write it down if you like. And so water in its various forms is really pretty powerful. Like rushing water, you can, harness that energy and use it for all kinds of things. When we talked about tides, we talked about the force of water and how we could get energy from that. Well, ice has has a certain amount of energy as well, and can create a great deal of force and enough force to break not just asphalts and not just aluminum cans, but also rocks and things as well. And so, when these frost heaves occur over and over again, you end up breaking apart the asphalt, and the road starts to break apart from the frost heaves. So why do sidewalks have lines in them? Seems like it wouldn't be that safe. People might trip. But the reason that sidewalks have lines is to actually create a little bit of space in between the different sections of the concrete so that the concrete actually has room to move around instead of just cracking. So the joints actually allow the cement to expand and contract without causing as many cracks. So that kind of leads us into talking about what's called ice wedging or frost wedging. Water fills in a crack, it freezes down in that crack. So there's a crack in the rock, the water gets down in there when it rains, then it freezes when it gets cold, and over a period of time, it actually forces the rock into pieces. So ice or frost wedging is our next type of mechanical weathering. So far we have talked about, water. We have talked about, I just forgot the second one. Well, you guys have it written down. The third one is ice and frost wedging, where the water enters cracks in the rocks, it freezes, and then it expands and breaks the rocks. All right, so we're going to take a look. Here's an example of a rock that has broken because of ice wedging. The water, it was probably a very small crack at some point. Water got in there, expanded, broke it a little bit, and kept happening over and over and over the years. And this is what you end up with. Okay, it also can create cracks and holes that rock climbers can use. Here's another picture of water getting into cracks or joints. Here is another picture of an actual rock over here and a diagram showing how it probably broke apart. Here are a lot of rocks that have broken over time because of ice wedging. All right, and we're actually going to kind of end right here. Hopefully, you guys are familiar with this particular picture. The old man in the mountain, the great symbol of the state of New Hampshire. I'm not from New Hampshire, but I have known about the man in the mountain for most of my life, even though I grew up in Maine, because he was very famous. But this rock formation at Franconia Notch in New Hampshire came crashing down several years ago, and we're going to talk a little bit more about that the next time. We're going to focus in on the old man in the mountain and then move on to some other types of mechanical weathering.